Aloha, and welcome to Hawaii 4-H Presents 4-H Hale Learning. Today's activity is the Introduction to Food Science. Supplies needed for this activity are mostly found in your home. There are substitutions available that you can use, and there are activity video clips that you can use as you follow along and do the activity, or just watch the video clips to see the activity. Supplies needed are pH strips, a food thermometer, some food items, and plates or towels. In the activities, you will learn about different causes of food spoilage, learn what the acronym FAT-TOM means, do an activity where you measure the pH level of different foods and take the temperature of different foods, and then identify the food spoilage issues of certain spoiled foods. To do these activities, you want to prepare the foods, tools, and other materials ahead of time, play the video to learn the background information, and then pause the video at each activity to follow along. At the end of the activities, you want to discuss and reflect what was learned. To prepare the foods for Activity 2, which is the pH and temperature activities, you want to get a variety of items. Some suggested items include pudding, orange juice, pickles, cheese, ketchup, plain yogurt, water, raw cabbage, raw celery, and lemon. For the third activity, the food spoilage activity, you want to prepare moldy bread 3 days ahead of time, if possible, by misting the bread with water and leaving it in a dish, and then leave out an apple 1 day ahead of time at room temperature. Before the activity, you want to add 1 tablespoon of vinegar to a glass of milk, place some pickles into a bowl, and place some beef jerky onto a plate. Introduction to rotten food. There are many different ways that food can be spoiled. Some are caused by bacteria and mold, and these can make food moldy and smelly. You probably won't get sick, though. Why is that? You're probably not going to eat it because it looks bad and smells bad. But there are other ways food can spoil, and you can't always see or smell them. These are food poisoning bacteria or foodborne bacteria. There is no smell, there's no change in color, and nothing you can really detect with your senses. You might not even know they're there until you actually start to feel sick. The best way to prevent this is to store and handle your food correctly to lower the chance for pathogens to grow. There's an easy way to remember which areas you need to combat so that you don't get sick, and that is through the acronym FAT-TOM. FAT-TOM is an easy way to help you remember the 6 factors that contribute to food spoilage, or any change to the food that causes it to become either bad tasting or dangerous. FAT-TOM stands for food, acidity, time, temperature, oxygen, and moisture. Bacteria need something to eat, and while fruits, vegetables, and starches are susceptible to bacterial spoilage, it's high-protein foods like meat, poultry, milk, eggs, and seafood that can harbor germs. These are the foods we consider perishable, which means they need to be kept in the fridge or freezer or preserved using any of the other techniques, such as pickling, smoking, canning, and so on. If it's an apple or an onion or a loaf of bread, you don't need to worry very much about it. It'll go bad eventually, but you can keep it at room temperature. The pH level is a measurement of how acidic or alkaline something is. pH values are figured out on a scale of 0 to 14, with lower numbers being more acidic. Water is considered neutral, with a pH value of 7. Foodborne bacteria prefer a pH level in the neutral area to the mildly acidic range. pH levels of 4.5 or lower are considered acidic and will slow the growth of bacteria. Pickling is a preservation technique that involves immersing foods in acidic liquid such as vinegar. It's not just the bacteria that can make you sick. In some cases, it's also the toxins they produce. You might kill the bacteria by cooking them, but those dangerous toxins will still be present. Temperature is one of the key factors in bacterial growth. Bacteria prefer a nice moderate temperature, too hot and they get cooked, which kills them. As a rule, heating food to 165 degrees Fahrenheit for at least 30 seconds is enough to wipe out any dangerous bacteria it might contain. The so-called temperate danger zone, the range of temperatures at which most bacteria thrive, extends from 41 to 140 degrees Fahrenheit. Your refrigerator or freezer will get you to 40 degrees and colder, like on a buffet. You want it to stay at 140 or hotter, which is too hot for bacteria. As long as it's first heated to 165 degrees Fahrenheit, it's safe to hold hot food at 140 degrees. But if it dips below that, you have to reheat it. Another thing bacteria need is oxygen. Confit is a classic technique for preserving food from the era before refrigerators. One of the most reliable ways of preserving food is by canning it, a process where the air is sucked out of the container by steam pressure, which also seals the container shut. Foods like dried beans and uncooked rice will last for a long time at room temperature. Indeed, drying foods is one of the earliest known methods of food preservation, such as jerky. Curing foods in salt and sugar can also deprive bacteria of the water they need. For our next activity, we are going to check the pH levels of different foods. You want to use a commercial pH strip. If you don't have one available, you can make one using red cabbage. Follow this link using homemade pH strips. Or you can just use the food science pH chart and discuss the different pH levels of different foods. It's a good idea to ask kids to try to figure out what they think the pH level is before you test it or check the chart. Watch the video to see how this activity is done.
It's more orange, okay. Just check the pH. Tell us what the pH is. Okay, we're making the assumption that the container did not change the pH of any of our products, okay?
What's lemon?
Okay, what's lime? Maybe lemon.
6. Wow.
What's lemon?
What's the key lime? Cheese.
Lemon 6.
Key lime, what's the key lime?
Cheese didn't change color?
6.
It was orange juice.
I did.
It didn't change? Okay, did we test everything?
No.
No? Okay. If we need to test some more, let's get, who has a bag? Who has a test color? Okay, which ones didn't we test? Let's get some more test strips. Test all the, till we get them all tested. Okay, and whoever's done with their part, if you can test water for me. But I went to pull up the pH chart for food. So we're going to compare with what the food science values are, okay? So let's start with the lemon. Okay, so it says the lemon juice is 2.0 to 2.6. Okay, so because we're using a color chart, we may not get as accurate measures as what we have on the chart, but I think 2.6, 3, I think that we're in the ballpark, okay? Okay, next, what else do we have? Orange juice.
5.
Okay, orange juice, oh wow, they have a different pH for California orange juice and Florida orange juice. It's 3.30 to 4.19. What did you come out with?
5.
Okay, all right, good job. What's next? Let's go to the, because this one is about produce, so let's see if I have a potato one. So potato, what was the pH that you got? 7? Okay, a little wider variation from the norm. They're saying that the pH for potatoes is 5.4 to 5.9. So what's the difference between what you're seeing and what they're seeing?
1 and 2.
Yeah, about 2 point difference. Okay, what else do we have? Oh, how about carrots? Because this is a produce chart.
Carrots is 6.
5.
Oh, 5.
Carrots is 5. Ooh, it says carrots is 5.88 to 6.4. Ballpark? Okay, but what is different about carrot? This is the first one that your reading is actually lower than what's on the chart, right? Most of the other ones, your reading was a little bit higher than what's on the chart. Yeah? Okay, that's interesting. Okay, anything else on the produce side? No. Okay, so you kind of get it. So now back to why were we checking pH? Right, okay, so we want to know which one has the most, but why do we care which one has the most? When we're talking about food safety, why do we care about pH? Right, okay, see, because if it's closer to the middle zone, like those things that were between the 6 and the 7, close to the middle, if we're going to 1 to 14, if it's acidity or the pH in the middle, then it's a more comfortable place, right? People, we like, well, we don't bathe in acidity or that kind of stuff, but in general, if it's closer to the middle where it's not on the extremes, they like it better. So foods that are acidic, they're less likely to encourage the bacteria to grow. Okay, things that are very alkaline, they're high pH, like soap, detergent. We ordinarily don't have foods in that category, but it's things like soap and detergent. They're not ideal for bacteria to grow. Okay, so for many of these foods, based on your pHs, do you think the bacteria like them? It's a good place for them to be? Yeah, most of them except for maybe like the lemon, right? How did the orange juice do compared to the lemon? Yeah, not as acidic, right? So it could be because it's the nature of the food, right? And a lot of times, you know, like when we looked at the chart, I told you that there's a different pH range for California versus Florida orange juice. It's because what the food is grown in can affect the nature of the food. In this case, the acidity. Okay? All right, so pH of the food is one thing that can affect bacteria growth.
The next activity is temperature. Using the same food items and a food thermometer, you want to measure the temperature of different items. Watch the video to see how this activity is done.
The other thing is temperature.
Yes.
You did? Okay, I have a different kind of thermometer. So my thermometer actually has what we call infrared, so that can check surface temperature. It just uses a little beam to check it. The other one, I have a probe just like you do, but I'm not going to use that because you already took that temperature. I'm going to take surface temperature using my infrared. Okay, so this orange juice is 77 degrees. Who temped that? Nobody. Oh, what did you have? 76.3? Okay. All right.
Was it again 77?
Oh, let me check again.
76.
Oh, it's 75.9.
75.
Okay, but just remember, temperature changes over time, right? Okay, so when I first bought it, it was in the refrigerator. So hopefully the refrigerator, I should have checked for you, I didn't check. Hopefully the refrigerator was at 40 degrees. So that means that it was at safe temperature, out of the danger zone. Okay, but now we're up to 77 degrees. And I bought it at 130. Okay, so 1:30, I was at Kaului Foodland. I bought these things, and they've been sitting out. So 1:30, it's about an hour and a half later, and we have from 40 degrees, we have what, 76 degrees, right? Okay, so quickly we can change the temperature. Now let's try this cheese. The cheese is 82.1 degrees. Let me check the temperature of the cheese that's sitting in this bag. If there's Oh, this one is 74.5. 74.5. And this is 81.7. Why is there a difference?
Because this one is out and that is in the back.
That's right. So these were all cold together, so they're kind of like helping each other stay a little cooler a little longer. Yeah. Okay. What else? So got it? So leaving foods out even for a little while. Remember, it's been like about an hour and a half, right? From the time I bought it and it was refrigerated. And now we've got that temperature range change, so we're in that danger zone between that 40 and 140. So what does that tell you?
Like a bacteria on it.
Yes, the bacteria is going to be growing because, right, we have time and temperature, so, and it's based on the pH, right? Most of these foods are in the pH range that the bacteria would like. Now, you all have a thermometer right now. If you had to take the temperature of these foods in front of you, how are you going to do it? Okay, do you know how to use a thermometer?
You have to stick it inside the food.
Right, okay. So this particular thermometer is what we call a tip read. So you see this skinny tip? That's what you need to get into your food. Okay? And then first you got to turn it on. That always helps. And then once you get those straight lines, then you know you're ready to temp your food.
It looks like 90 something.
It's 90 something?
Yeah.
What did you temp?
Is it supposed to be like this?
I just turned it on and just
Oh, it's taking ambient. So it might be saying that 82.7 is the temperature of the room.
Just
Okay.
going down.
It's going down? Okay. So from the time you take the temperature to you take it out, and now it's reading the room temperature, right? So when you take the temperature, record it next to the food. And let's make a note that the time we're taking our temperature at 1 dead. Okay, let me go to my handy dandy. It's 305. Okay, we're taking our temperature at 305. Okay, write it down because you're going to forget.
This one has some.
Yes, even though it doesn't look wet, all of these foods have enough moisture to make it ideal for bacteria to grow. Okay, so now that we know that we're looking at potential pathogen breeding areas, what are we going to do? Come on, put on your problem-solving hat because we have all this stuff sitting here. What are we going to do?
eat it.
Eat it! Very good! We want to eat it now!
Our last activity is a food spoilage activity. Using the items you've prepared, have you fill out the following worksheet or discuss it as a group and complete the worksheet together. Have them identify each food sample, observe and write the characteristics, test for pH and temperature, and determine which fat Tom factor or factors contributed to the changes in the food. Share and discuss what you found during all of the activities and talk about the different areas of the Fat Tom acronym. Mahalo for joining us for this 4-H Hale learning activity.